Hey guys, today we're going to be looking at different ways to categorize numbers. So the first one is the capital N, which shows you the set of natural or counting numbers. Now if you don't know what natural or counting numbers are, they're simply the 0, 1, 2, 3 for the ways you count. The smallest counting number must be 0, and these must be whole numbers, so that's why we call them natural or counting numbers. So we can't have any negatives here, it's all positive. Now Z, capital Z, represents sets of integers. Now integers are like the first set of natural counting numbers, but we can also include the negative part as well. So as long as they're whole, we can include the negatives as well. So the 0 is also included, and it's positive or negative 1, positive or negative 2, but no decimals or fractions. Now Q is the set of all rational numbers. Now rational numbers are numbers that are easy to change from, say for example, decimal to a fraction, or easy to justify like that. So for example, I would say any numbers that can be written as a fraction form, where it's an integer over an integer. So say for example, numbers like 2 over 5, 7 over 2, or 16 over 3, all these numbers are integers. Now if I ask you guys what, say for example 3, the whole number 3, this natural number here, if I ask you whether this is rational or not, what would you guys say? Think about it, guys. Now for those who said it is rational, well done, because 3 is basically 3 over 1, isn't it? All of these whole numbers are basically over 1, but we don't write anything over 1, do we? So that's why this one is also written in this kind of form, so therefore it is rational. So say for example, like decimal numbers, say for example 0.75. Is this a rational number? Yes it is, because 0.75 is equivalent to 3 over 4, which can also be written in that form. So these are all rational numbers. Okay, so that is notified by the capital Q. Now the next one is Q dash, which also we can call the complement of capital Q. So it's the same thing as the rational number set, but I just put a dash on the top of the Q. And it's called a set of irrational numbers. Now irrational is the opposite of rational. So these numbers, examples I can give you are pi, root 2, root 3, a lot of root numbers are irrational. Because say for example pi, guys, pi is 3.14, and it goes on and on infinitely, doesn't it? So there's no specific pattern of how they go on infinitely, and they just keep repeating on and on until forever. So these kind of decimals, we cannot convert to a fraction. They're just as it is, because it's never ending and there's no specific pattern. Same with root 2, same with root 3. If you put this into your calculator, guys, you know that the decimal will never end. It will just go infinitely, and as I said, there's no specific pattern. So these are irrational numbers. They are not be able to convert it into like a fraction form like this. Now another one is R, capital R, which is a set of all real numbers. So real numbers are just anything that's real. So if it's able to put on a number line, so it can be placed on a number line, then it's real. So basically every number is real. So it can be rational, irrational, natural, integer, whatever they are, they're all real numbers. Now, I'm going to show you this aspect here where it's Z with the positive in the power. So it's Z plus. So that plus just indicates positivity, plus, positive. So it means set of all positive integers. Remember how capital Z represents the set of all integers? But the positive there indicates that it must be positive. Now the next one here is Q with the positive on the top as well. Now remember, Q is rational numbers, but that plus just indicates positive. So we just want positive rational numbers. That's Q plus. Now last one here is R plus. So capital R with the plus on the top means set of all positive real numbers. Capital R just means all set of real numbers, but the positive means we all want just positive, just the positive part. So these three ones are also very frequently used in exam style questions. So make sure, guys, be familiar with all of these capital symbols, because that's what we're going to be using to categorize different numbers. So let's go on to the questions. Okay, question 1. Indicate with a tick where the numbers belong to. So what I'm going to do is that where the numbers don't belong, I'll just put a big fat cross on it, and if it is, I'll put a tick on it. So let's go through one by one. So see how we have 1, 2, 3, 4, 5, 6, 7, lots of different numbers. I'm going to categorize them into my relevant categories. So first of all, let's go to root 5. Now root 5, guys, is approximately 2 point something, and it's what we can start with is Q. What does Q mean, guys? What is Q? What kind of set is Q? Q is a set of all rational numbers, isn't it? Now, first of all, remember how I told you irrational numbers must be able to be converted into a fraction, where it's integer over an integer. But this number here, root 5, as I said, it's going to be 2 point something that goes on forever. You can even check this on your calculator, and it grows infinitely with no specific pattern. So it is not possible to change into a fraction. So it's not going to be rational. We can't put it into those sets. Now R is real numbers, set of all real numbers, and I said if it's able to be put on a number line, it's real. So whether it's irrational, rational, natural, or whatever it is, as long as you can distinguish it on a number line, it is real. So root 5 is definitely real. We'll put a tick there. Now, okay, let's look at Z, all sets of integers. Remember, integers must be, it could be negative, it could be positive, but they must be whole numbers. So root 5 is definitely not whole, so we put a fat cross there. Now, Q dash, remember how Q dash is the opposite of Q? It's the complement of Q, which means it's all the set of irrational numbers. Now, we've just said that it's not rational, so therefore it must be rational, right? So the complement, yes, we do tick. Now, N is all set of natural numbers or counting numbers. Now, these natural numbers, we can relate it to the Z here, all sets of integers, but we just don't include the negative part. So 0, 1, 2, 3, 4, and again, they must be whole because they're counting numbers. So root 5 is not whole, so therefore it's not natural. Make sense, guys? So that's what we do for root 5. Now let's look at the next one. 3. 3 is a pretty simple number, isn't it? First of all, can you guys tell me if it's rational or not? It's definitely rational. 3 is 3 over 1. Remember I told you? So therefore it's rational, because it can be changed into a fraction form. Now, is it real? Do you think it's a real number? Yes, it is. It's, as long as it's a number that is putable in a number line, then it's going to be real. So therefore 3 is real. Now Z, what can you tell me about Z? It's all sets of integers. Now, integers are whole numbers or counting numbers, but they can also be negative. But they can't be decimals or fractions like that. 3 is an integer, so therefore it is an integer because it's a counting number, so whole number. Now, Q dash is the complement of Q. Now, we've said it is Q, so the complement must not be. We can't have, so remember how Q dash is irrational numbers? 3 is definitely rational. Now, N, natural numbers. Remember how natural numbers are just basically integers, but only the positive parts. So 3 is a positive integer, so therefore, yes, it's natural. Now, let's go to 1.2. 1.2 is it rational or not? Are we able to change that into a fraction form, guys? 1.2 is 12 over 10, isn't it? And if we divide both sides by 2, top and bottom by 2, we get 6 on 5. So therefore, this number, this decimal, is equivalent to 6 on 5, so we can change it to a fraction. And the main property of a rational number is that it is able to be changed into a fraction form where it's an integer over an integer. And therefore, yes, it is. So now, is it real? Yes, it is. If it's a number, it's real. Okay, if it's a number that doesn't look really weird, comes from an imaginary world, it is real. Now, Z is an integer. Now, integers must be whole, so therefore this is not an integer. Q dash, is it a complement of Q? Is it irrational? I've just said it's rational, so it can't be irrational. Now, N, is it natural? Now, natural numbers must also be whole. That's obviously not whole, so therefore no. Okay, so only 2 boxes were ticked there. Let's look at root 4. First of all, guys, let's simplify root 4. Root 4 is equivalent to 2, right? Because 4 is 2 squared, so root of that is just 2. So 2, let's just look at 2 now. Is 2 rational? any whole number is basically itself over 1. 2 is equivalent to 2 over 1, so it is an integer over an integer, so therefore yes, it's rational. Now, is it real, guys? If it's real, it's any number on a number line. 2 is definitely part of our number line, so therefore yes, it's real. Now, z, is it an integer? Integers must be whole. Doesn't matter if it's positive or negative, but they must be whole. And obviously 2 is a whole number, so yes, it is an integer. Q dash, because we said that it's rational, it can't be irrational, so no. Now, is it natural? Natural numbers are positive integers, so therefore 2 is a positive integer, so yes, it's natural. So we're getting the hang of this, guys. It's pretty repetitive, isn't it? So I'm pretty sure with every number you can distinguish whether it relates to any of these categories. But anyway, pi is 3.14 blah blah blah. It goes on and on forever. I'm not sure how many of you guys can memorize after the decimal point, but it goes on and on infinitely without specific pattern. So therefore it must not be irrational. It's not rational because we cannot change it to a fraction form. Is it real? Yes, it is. Numbers are all real. Z, is it an integer? Integers must be whole, so no. Q dash, well, because we said it's not rational, it must be irrational, so yes. Is it natural? Because pi is not a whole number, it cannot be natural. Now let's look at -9, guys. -9, is it rational? Well, yes, it is a whole number, isn't it? So all whole numbers are rational because it can be put over 1. Is it real? Yes, it is. Even if it's negative, it can be still put on the number line. Now, is it an integer? Integers are whole numbers where it can be both positive or negative. So because this is a negative whole number, it is definitely an integer. Q dash, is it irrational? -9 is definitely a rational number, so it can't be irrational. Now, is it natural? Natural numbers must be positive, so this one can't be natural as well because it's negative. Now we'll do one more, 0. 0 is a very neutral number. We don't call it positive or negative, but let's still try. Is it rational, guys? 0, again, is a whole number that's put over 1. 0 is equivalent to 0 over 1, so yes, it is rational. Now, is it real? It's a good part in a number line. It's the center point of a number line, isn't it? So definitely yes, it's real. Is it an integer? Now remember, integers are whole numbers that can be both positive or negative, including 0. So 0 is also an integer. Is it irrational? We've just said it's rational, so it can't be irrational. Is it natural? Now remember how natural numbers are all positive integers? The smallest natural number or counting number is 0. So 0 is inclusive, so therefore it is natural, okay, or counting. So guys, these alphabets here are symbols of different categories of numbers. Make sure you are very familiar with those.